Okay, hi guys. Hi, welcome. Fine, hope you can see everything okay. My name's Paul. And yeah, I know you're all sad and depressed at home without enough maths to do, so I'm here to rescue you and give you a couple of questions a day just to keep you going. Now this is AS level and A level, so if you're not doing those things or you're just a general person, you may not be as excited about it, but you might be. We'll see. Okay, I'm not going to bang on too much. I think we're only going to do 20 minutes today just to get started. Two questions. I'll do one AS level question and one A level question. So yeah, time is of the essence. All I want to say is subscribe here. I'll be here every day at 10, Monday to Friday. Follow me on Instagram, Paul Tutors Maths. I think I'll probably start posting the questions the day beforehand on there, so you can do them in advance. Wouldn't want to use the term homework, but advanced preparation. Anything else? Yeah, I mean, I might start putting other topic-specific questions on my YouTube, or topic-specific videos, rather, explaining different topics. But for now, let's just get going. I'm doing EdXL questions to start with. I'm doing kind of slightly harder exam questions. Today's not too crazy, but maybe we'll increasingly get a bit more extreme. But I really just wanted to focus on getting the exam style and the sort of slightly more difficult questions done. So we're doing it. Enough chat, I'm getting started, okay? Okay, first one. So this is an AS level question, so year 12, it's a pure question. And there it is, the equation kx squared plus 4kx plus 3 equals 0. So why don't I write it out? Can't be bad, cannot be a bad thing to do, just to pop it on here. Okay, and first thing to note is it's saying prove that 0 is less than or equal to k is less than 3 over 4. If I see anything that says prove or show or that kind of language and they give me the answer, don't touch it. I'm not going to be touching this answer, all right? Leave that. Don't start from that and work your way backwards. It's just not, unless you're really in desperate straits, use the stuff you've been given. They've helped you. They've told you what the answer is, so we know what we're aiming for. Other thing they've said, no real roots. Okay, so, well, back in the day at your first christening, you were taught about the quadratic equation. So let's just bust that out. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Bit shaky today, the tech. Work in progress, all right? We'll try and get that slickened up as we go along. But fine, so you were taught that back in the day. And in GCSE, you spent your whole lives going through this and working out solutions for x. Because by the way, this is a quadratic structure, I should say. I know the k is a bit stressful. I know that can be a bit stressful. But you've got x squared and x and a number. So it screams out quadratic formula. What is the part of the quadratic equation which started to cause us problems as we go into AS level? It's this part. B squared minus 4ac. It's got a lovely name. Let's just write it out again here. Discriminant. And I guess the traumatic thing about it is, if that is negative, you've got a square root of a negative and you cannot do it. If it's positive, you can do it. Things are great. If it's 0, you also can do it. Let's not do the full test, and for time I'm just being a little bit quick, but the spoiler alert is that the connection between the question no real roots and this discriminant, b squared minus 4ac is less than 0. That is what we're dealing with, okay? I'll do a quick recap at the end, but I'm going to just turbo through for time. So, actually going back up here, I can tell you what my stuff is. A, B, and C. It's the numbers in front of the x squared, the x, and just the number at the end. So it's the coefficients, if you like. Just write them out again. A equals k, B equals 4k, C equals 3. And then it's just a case of plug and play, really, isn't it? Let's do it. 4k squared minus 4 times k times 3 less than 0. Joy to behold. Cracking on, 16k squared minus 12k is less than 0. Okay, and it's round about here, actually. So we've actually done the hard stuff. Maybe a mild recap before we go on. We were given an equation. It's a quadratic. There's some weird coefficients with k. They said, show that if k is in a certain range, there's no real roots. No real roots. Well, that means b squared minus 4 ac is less than 0. ABC. Plug them in. We're here. And this is the point where you're going to be tempted to just relax. You're going to be tempted, if I know you well, to just sort of maybe factorize like this. Oh, that would be just 3, something like that. Yeah, pull out a 4k. Yeah, is that what you want to do? And then you want to just jump in and say something like 4k is less than 0. 4k minus 3 is less than 0. I know that's you're just dying to do it. I can feel it. No, you're not doing it. You've got quadratic inequality. Quadratic inequality. And there's only one way you should always do it, and it's to sketch the graph. A rough sketch of the graph. I'm not asking for anything mind-blowing, but you should do it, because otherwise things will go wrong for you. So okay, I don't mind. Let's not throw the baby out with the bathwater. You had that factorized. 4k minus 3. I'm not going to say that's less than 0, but I am going to look at that for the roots. So the roots of your thing, your quadratic, will be k equals 0, or 4k equals 3, which is k equals 3 over 4. Rough sketch. Let's push that up a bit. Okay. Time is of the essence. 0, 3 over 4. Rough sketch. Now finally, examine it. Examine it well. The graph is less than 0. There's our graph. Here is where it's less than 0. This little archy bit at the bottom. Boundaries 0 and 3 over 4. So the way you could write it is 0 is less than x is less than 3 over 4. Always a bit of a funky thing, that. Maybe I'll spend more time a different day, just if anyone wants to know how you get from this to that. Sometimes a little bit tricky. Also, if your solutions are above the x-axis, different way of writing it. But there you go. That is what we want. Only a little funky thing in this question, because just a mildly tricky addition, and this is maybe where the kind of EdXL new A-level math syllabus is starting to come into its own, is here you've actually got a less than or equal to in the question. So I'm not sure if I want to write that out in my working here, and I'm just doing that, just kind of doing this rough for you guys. What we've just solved wouldn't have that equal to as well. So the way you check that equal to is, you need to have the wherewithal to go back to the original question and plug it in for k. So if I just write that again, kx squared plus 4kx plus 3 equals 0. So if I just plug in k as 0, 0 times x squared plus 4 times 0 times x plus 3 equals 0. Now, of course, these two bad boys are gone, because 0 times anything is 0. So you just end up with something, and actually, yeah, it was equal. So you end up with 3 equals 0. Just gobbledygook. So you'd say something like, well, therefore k equals 0 also no real roots, because there's no solutions. And that's how you get to your answer. You've got your between 0 and 3 over 4 from your quadratic inequality, which you set up using the discriminant. And you've just got that little extra cheeky bonus, maybe 1 marker, maybe 2 marks, it depends how much they want to push you on it, for seeing that k equals 0 is also a problem. Okay, time is precious. That's your AS level question. Time to do an A level one. What do I fancy? What do I fancy? What do I fancy? Oh, I think this is a good one. Yep, let's do this. Let's do this. Okay. It's Monday. I mean, you know, we need to warm you up. We need to get you warmed up for the week. Hopefully that's happened to some extent. No time to rest though. No time for a breather. It's like, yeah, that's like I was doing a workout today, and you get 30-second breaks in between. You know, I guess this little chat that I'm doing here is giving you a mild 30-second break. Other than that, no. Okay, we're back in. So what's going on here? Probably I don't have time to write out the whole thing, because then we'll be at the end of the time. But let's just write out something or other. See if I can just move that down so it's in shot. Okay. Right. They said show that dy by d theta equals that. They said it. Say again. Show. You've got to show. So, I mean, some people would like to start with that sine 2 theta and try and work back and get to it, but it's just, I would not be looking to recommend that unless, you know, serious health warning goes with that. Instead, that's your answer. It's something to aim for. They've helped you. They might have not given you that. Thank them. Go to edXL and thank them and say, honestly, I'm really grateful for what you've offered me here today. So, basically what we need to do is differentiate it. And then we can check at the end if it looks similar to what their alleged answer is. Which rule could this be? Which rule could this be? Oh, there's something on the top and there's something on the bottom. Oh, it's a kind of fraction-y type. It's the quotient rule. It's the quotient rule, okay? Quotient rule. And what have we got? It's the old dy by dx equals, are we going to go for u notation? Yeah, let's say u dash v minus v dash u over v squared. Bish bash bosh. Okay, and you have to call the top one u, and you have to call the bottom one v. Let's write them out. U equals 3 sine theta. V equals 2 sine theta plus 2 cos theta. Just in case you're having a panic attack or anything, u dash is du by d theta. It's the derivative of the top one. And v dash is the derivative of the bottom one. It's just a notation thing. Maybe it's me being lazy, or maybe it's just slick, precise notation. It's for you to decide. Okay, differentiating them both. 3 cos theta. Differentiating this guy. 2 cos theta minus 2 sine theta. Turbo. Derivative of sine is cos, derivative of cos is minus sine. That's about the story. Then it's just a case of plugging in. So we'll just go and put that in a box. It's always good to boxify the good stuff, innit? Right, cracking on, dy by dx equals u dash v, 3 cos theta, times v, which is 2 sine theta plus 2 cos theta, minus v dash u, 2 cos theta minus 2 sine theta. Did I leave myself enough space? Probably not. Times u, which is 3 sine theta. All over v squared. So it's that whole shenanigans at the bottom squared. So there you go, 4 minutes to go, right? 4 minutes to go of this. We've already done phase 1 of this question, mild recap. And phase 1 is just basically knowing the quotient rule. And I think you do get it in the formula sheet at the start of the exams these days. You pretty much do. So, you know, it's there. I think it is there as a sort of safety net. We're not going to rely on it. We are not going to rely on it, but it's there as a safety net. Yeah, knowing that u's on the top and v's on the bottom, differentiating them, plugging them in, and assuming I've plugged everything in right. I mean, I could have mucked something up. It's very possible. We're just going to keep going and see if we can get it to look like what they've got there. I mean, the rest of it now is basically algebraic manipulation. So how is your algebra? Can you get this simplified? Can you get in and get out and get the job done? I am going to certainly try. Top line, 6 sine theta cos theta plus 6 cos squared theta. Alright, that's that first thing, the 3 cos theta times through, then minus everything that's about to come. So let's keep it in a bracket. Let's keep it in a bracket. Minus 6 cos theta sine theta. Well, okay, I'm going to just keep that minus there. I was almost going to multiply it out, but that was not the thing to do in the end. Okay. Let's pick things up. Let's pick things up. Whew. Sprint for 30 seconds. There it is, minus minus plus 6 sine squared theta all over monstrosity on the bottom. Okay, let's do some turbo simplification here, but I mean, you need to do more of these questions. The more of them you do with this algebraic manipulation, the fewer mistakes you'll make, the fewer minus signs will be lost and picked up, and things will go more smoothly. Not really a proper sentence there that I got out, but I think you get the picture. So, anyway, I'm seeing these things cancelling. 6 sine cos theta. Smash them off immediately. What else am I seeing? Okay, 6 cos squared theta plus 6 sine squared theta. Hello! Sine squared theta plus cos squared theta equals 1. Never before written vertically. World record first exclusive. So that means 6 cos squared theta and 6 sine squared theta will be 1. So you've got 1 on the top. That was good. Maybe we should take a minute to reflect. I mean, that is actually something pretty messy up there. Has come down to something almost couldn't be simpler. It's just a 1 on the top. What? Oh no, it's a 6. Whew. It's all come down. Still pretty simple though. And it's almost as if they planned it like that or something. I don't know. So, whoever wrote the question. The bottom. Now the bottom, well, if I'm just checking our final question here, the way it's written, you know, the elephant in the room is that it's sine 2 theta, whereas both of these are sine theta. So there's maybe a couple of different ways, but I think I can see what to do, and I think we're just going to expand it out. 4 sine squared theta plus 4 cos squared theta plus, now there'll be cross terms here. By the way, I'm kind of just going quickly over it, but it's all this squared, so really you have to write it out as one of them times another one of them and do your FOIL and to get all 4 terms. The 2 cross terms are going to each be 4 sine theta cos theta, so that you're going to get 8 sine theta cos theta on the bottom. Okay. Okay, continuing to simplify. On the bottom, 4 sine squared plus 4 cos squared is 4. Same chat as before. Sine squared plus cos squared equals 1. 4 of them is 4. 8 sine theta cos theta identities, double angle formula. 4 sine 2 theta. So that was what we were waiting for. That elephant in the room really has been sat on by a larger elephant, if you like. Yeah, let's get the identity written over here. Sine 2 theta is 2 sine theta cos theta. So I've just used that. And yeah, so it's 4 sine 2 theta. All that's left to do then, pull out 4 on the bottom, 1 plus sine 2 theta. Would you look at that? It's looking kind of familiar. It's looking kind of like what we wanted. And I guess this is maybe, again, well, you maybe you wouldn't have seen this in the questions of yesteryear. Maybe this is just an element, again, of new A-level specification. I feel like you might panic here because there's a 4 on the bottom. What you're really going to have to say is bring that, that's equivalent to 6 over 4 over 1 plus sine 2 theta. Convince yourself that's the same. Please do. I mean, that is the same thing. And have we done any crimes? Have we committed any felonies? It says it's a rational constant, so it doesn't say it has to be a whole number. It doesn't say it has to be an integer. Just rational. By the way, just as it happens, you might want to say that's 3 over 2 if you're a keen simplifier, born and bred. Then there you go. So no, we've not committed any crimes because 3 over 2 is rational. A is 3 over 2. No problem. No problemo. Okay, time up for today. Mild recap of that one. That's what they threw at us, all right? They said, here's something, it's a fraction. There's trigonometry top and bottom, do what you can. We saw it, we noticed it was the quotient rule, hopefully. We differentiated our stuff, top one U, bottom one V, plugged them in, get some stuff, and then the rest was just simplifying. The only other little funky doodah that you needed was the old 2 sine theta, or sorry, sine 2 theta equals 2 sine theta cos theta. You also need the cos squared theta plus sine squared theta equals 1, but that's not too dramatic, I hope. And A equals 3 over 2. Okay, that's enough for just now. Thanks very much for joining. Subscribe to this page on YouTube. Follow me on Instagram, Paul Tutors, at Paul Tutors. And you can find me Paul Tutors Maths. Back every day at 10 AM. Thanks very much, guys.